Okay students, let us discuss about crystal field splitting in octahedral coordination entity. Before going to the exact discussion regarding this concept, before that one, let us discuss about some basic points regarding the d orbitals. There are 5 d orbitals. You already know about those 5 d orbitals. Which are those? dxy, dyz, dzx, dx square minus y square, and dz square. These 5 d orbitals are called as, these 5 d orbitals are together called as degenerate orbitals. What they are called as? Degenerate orbitals. Degenerate orbitals anta karitare. Degenerate orbitals means what? Having same energy. Energy is same. In the d orbitals, they are present in same energy. That is the meaning of degenerate orbitals. And the d orbitals are energy same aiti anta artha. Okay, that is degenerate orbitals anta karitare. It is applicable for this concept. Degeneracy is applicable for p orbitals also. Px, py, pz are having same energy. This is also concept. Means degenerate orbitals means orbitals with same energy. Here 5 d orbitals are there. They are dxy, dyz, dzx, dx square minus y square, and dz square. In the metal orbitals, in the metal atom, these 5 d orbitals are having same energy. Therefore, they are called as degenerate orbitals. And here we are having their structure and shape also. Okay, these are the shapes of 5 d orbitals. Okay, there are 2 types again. 3 orbitals, dxy, dyz, dzx orbitals are called as non-axial orbitals. They are called as what? Non-axial orbitals. Why? The lobes of these 3 orbitals are present in between the coordinates or in between the axis. Our lobes axis madhya non-axial orbitals. Okay, these 3 are called as non-axial orbitals and they are called as T2G set of orbitals. Non-axial orbitals, non-axial d orbitals. 3 non-axial d orbitals are called as T2G orbitals. Please remember, the lobes are present. Where does the lobe present? Where do the lobes present? For the 3 d orbitals, they are present in between the axis. Okay, in between the coordinates. Okay, now come to the discussion regarding the second set of orbitals. Means axial orbitals. Axial orbitals means what? These 2 orbitals are having their lobes located on exactly along the axis. Axis and lobes are axial orbitals. These axial orbitals are called as EG set of orbitals. Here you have to remember the direction of the lobes for these 5 orbitals. 3 set of orbitals means 3 orbitals are having their lobes in between the axis. Please remember this point. Second one, 2 orbitals are having their lobes exactly on the axis. Axis mein yavadavu dx square minus y square, dz square orbital. Our lobes axis mein. In between yavadavu axis gal madhya yavadavu dxy, dyz, dzx. Please remember this concept. This is the basic point you have to remember to understand the crystal field splitting in the coordination complexes. Coordination complex crystal field splitting. Split ಆಗೋದನ್ನ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಮೊದಲು ಈ ಆರ್ಬಿಟಲ್ಗಳ ಬಗ್ಗೆ ನಿಮಗೆ ನಾಲೆಜ್ ಇರಬೇಕು. ಅವರ ಲೋಬ್ಸ್ ಎಲ್ಲದವು ಗೊತ್ತಿರಬೇಕು. Now we have discussed that one. Okay. Now before the formation of the coordination compounds, these 5 d orbitals are having degenerate condition. Degenerate condition means what? They are having same energy before forming the bonds. with the ligands in the coordination compound. Coordination compound ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆ ಅವುಗಳ ಎನರ್ಜಿ ಏನೈತಿ ಸೇಮ್ ಐತಿ. ಅವಾಗ ನಾವು ಏನಂತ ಕರಿತೀವಿ ನಾವು degenerate orbitals ಅಂತ ಕರಿತೀವಿ. This is in which condition? Before the formation of the bonds by the metal atom with the ligands. Key point and value. Okay, now come to the exact concept. What is that one? Crystal field splitting in octahedral coordination entity. Octahedral coordination entity means what? What we have to discuss here? We have to discuss that 6 ligands are approaching the central metal atom or ion. Then only we can get the octahedral geometry. Here we are going to discuss regarding the approach of 6 ligands with the central metal atom. Please remember this one. Okay. Now this is what octahedral structure in 2-dimensional. In 2-dimensional, it is like this. It is like this. These are the 4 corners. We are having here 4 corners square. Okay. One point is the z-axis. I am indicating z-axis here. It is above. Okay. But the same z-axis is having below point also. One is below, one is above. This is the 3-dimensional structure of the octahedron. You already know that one. You already got the structure. Here I will assume I will assume the 3 coordinates. And I will assume kuda madkodani. ಹೌದಾ? ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ನೀವು ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ಅವು ಆರೋ ಮಾರ್ಕ್ ಏನನ್ನ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತಾ ಇದಾವು? ದೇ ಆರ್ ದ arrow mark in the diagram are indicating the approach of the ligands, the direction of the approach of the ligands with the central metal atom. ಆ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ligands ಅದಾವು ಅಂತ ತಗೋತಾನೆ. ನಾನು ಅದೇ ಪೊಸಿಷನ್ ಒಳಗೆ ಏನು ಮಾಡಬಹುದು? ಆಕ್ಸಿಸ್ ಗಳನ್ನ ತಗೋತಾನೆ, ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಗಳನ್ನ ತಗೋತಾನೆ. Each are perpendicular to one another. You all know that. ಹೌದಾ? ಅವು ಯಾವ ರೀತಿ ಅದಾವ ಈಗ? ಯಾವ ರೀತಿ ಅದಾವ ಈಗ? ಹೌದಾ? ಈ ರೀತಿ ಇರ್ತಾವು. ನಿಮಗೆ ಗೊತ್ತಿದೆ ಈಗ ಆಲ್ರೆಡಿ. This is x, this is y. Where is the z? Towards you or away from you. ಹೌದಾ? ಆ ರೀತಿ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡೆ ನಾನು. Each are perpendicular to one another. ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ನಾನು ಅದನ್ನ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡೆ ಅಂತ. This is the condition of ligands and the axis in octahedral coordination entity, in octahedral geometry. Now also you have to assume the presence of the d orbitals in the metal atom or metal ion. ಹೌದಾ? ಇದೇ metal ion ಒಳಗೆ ಏನಿರ್ತಾವೆ ಈಗ? ಇದೇ d orbitals ಗಳು ಇರ್ತಾವು. d orbitals ಅದಾವ 5 d orbitals. Here dxy, dyz, dzx. ಇಲ್ಲಿ coordinates ಗಳನ್ನು ನಾನು ಬರೆದೆನಿ. Along the coordinates, on the coordinates, dx square minus y square and dz square orbitals are present on the coordinates. They are having their lobes on the coordinates, and these 3 orbitals are having their lobes present in between the coordinates. ಗೊತ್ತಾಯ್ತು ಈಗ ಹಂಗಾರ? 3 ಆರ್ಬಿಟಲ್ಗಳು dxy, dyz, dzx. ಅವು ಆರ್ಬಿಟಲ್ ಎಲ್ಲಿ ಬರ್ತಾವು? ಎಲ್ಲಿ ಬರ್ತಾವ ಆರ್ಬಿಟಲ್ಸ್? ಇವುಗಳ ಮಧ್ಯ ಬರ್ತಾವೆ ಈಗ ಅವು. ಇಲ್ಲದವು. ಹೌದಾ? This is for dxy, dyz and dzx orbitals. And for dx square minus y square and dz square, they are having the orbitals along the coordinates. Coordinate ಗಳ ಮೇಲೆನೇ ಬಂದ್ಬಿಟ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ಸಿಗಂಗ. Okay? Now, the d orbitals are having electrons. The metal d orbitals are having electrons. According to the postulates of crystal field theory, ligands are considered as point negative charges or dipolar molecules. Okay? The negative end will be towards the in polar molecules negative end of the ligand will be towards the central metal atom. This is the concept of postulates of the crystal field theory. Okay, in this direction ligands are approaching, they are negatively charged. In the same direction, in that direction only, these two orbitals, dx square minus y square and dz square orbital, these z square orbitals are having their lobes. Okay? It means for dx square minus y square and dz square orbitals, the repulsion is more. Repulsion is more by ligands. Is it? For these two orbitals, repulsion is more. Why? This is lobes of the dx square minus y square and dz square orbital. This is one ligand. They are approaching directly. They are approaching directly. They are approaching directly. In the same direction, the ligands are present and orbitals of these two, the lobes of these two orbitals are also present. Therefore, repulsion is more. Why repulsion is more? These orbitals are containing electrons. Ligands are negatively charged. What is happening here? Repulsive force takes place. Therefore, these two orbitals experience more repulsion. Why? These two orbitals are having their lobes located on direction of the approaching ligands. Okay? Now, come to these three orbitals. They are having lobes in between the axis. They are having lobes in between the axis. They will experience repulsion, but not as much as these two orbitals. Why? They are having lobes in between the axis. This is the direction of the ligand. This is the presence of the lobe. This is the direction of the ligand. This is the presence of the lobe. This is the direction of the ligand. This is the presence of the lobe. Or this is the presence of the lobe. Okay? This condition is applicable for 1, 2 and 3 orbitals. Which are those? dx1, dyz and dzx orbitals, or t2g set of orbitals. It means now I want to summarize the concept. Okay? What is happening here? In crystal field splitting of octahedral coordination entity, 6 ligands are approaching the central metal atom in octahedral direction. Okay? In this condition, dx square minus y square and dz square orbitals are having their lobes in the direction of the approaching ligands. Therefore, they will experience more repulsion. Therefore, because of more repulsion, energy of these orbitals increases. Energy of each set of orbitals increases. Okay, that repulsion energy general concept. If repulsion increases, energy increases. Okay, now for dxy, dyz, dzx orbitals, repulsion is less. Why? Because these three orbitals are having their lobes in between the axis. These lobes are not present along the direction of the approaching ligands. They will have less repulsion. Their energy will be lower than the other two orbitals. This is the concept of crystal field splitting in octahedral coordination entity. Because of the approach of the ligands, degeneracy of the d orbitals is vanished, is removed. The d orbitals have lost their degeneracy. ತಮ್ಮ ಡಿಜೆನರಸಿಯನ್ನು ಈಗ ಕಳ್ಕೊಂಡು ಹೋಗು ಅಂದ್ರೆ ಅವು ಅಷ್ಟು 5 ಆರ್ಬಿಟಲ್ಸ್ ಗಳಿಗೆ ಎನರ್ಜಿ ಸೇಮ್ ಇಲ್ಲ, ಚೇಂಜ್ ಆತೀಗ. Eg set will have a higher energy because of more repulsion. T2G set will have the low energy because of less repulsion by the ligands. Clear or not? Okay. Now let us discuss about this crystal field splitting in octahedral coordination entity with the diagram. This diagram is noted. Now this is the representation of the 5d orbitals before the formation of the bonds. by the metal atom with the ligands. Now we have assumed this condition when ligands are approaching the d orbitals in spherical field. In spherical field, what happens? All the 5 d orbitals will experience the repulsion, but the magnitude of repulsion is same. Same type same amount of repulsion ಆಗ್ತದೆ 5 orbitals ಗಳಿಗೆ. ಯಾವಾಗ ಸ್ಪೆರಿಕಲಿ ಇದ್ದಾಗ ಲಿಗ್ಯಾಂಡ್ಗಳು ಸ್ಪೆರಿಕಲ್ ಫೀಲ್ಡ್ ಆಗದಾವ. ಈಗ ಅಂದ್ರೆ ಅಷ್ಟು ಸುತ್ತ ಕರೆಕ್ಟ್ ಆಗದಾವ. ಈಗ ರಿಪಲ್ಷನ್ ಐತಿ, ಜಾಸ್ತಿ ರಿಪಲ್ಷನ್ ಐತಿ, ಅದು ಸೇಮ್ ಅಮೌಂಟ್ ಒಳಗೆ ಐತಿ. ಅದಕ್ಕೆ 5 ಆರ್ಬಿಟಲ್ಗಳಿಗೆ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗ್ತವೆ. Now this is in the case of octahedral geometry. In octahedral geometry, what happens? The each set of orbitals will experience the more repulsion. Their energy has risen than 3 orbitals. These 3 orbitals into this set of orbitals will have less repulsion. Therefore, their energy is decreased. This is the diagram which is showing the crystal field splitting of the d orbitals in octahedral coordination entity. Understood or not? Okay. Now this is what? This is pole delta O. Delta O means what? Crystal field splitting in octahedral coordination entity. O stands for octahedral coordination entity. Okay. This is what? The energy difference for each set of orbitals in comparison with these 5 d orbitals. Okay. Here 5 orbitals are present. 5 orbitals are present totally. The energy of these 2 is more than these 3, is it? Therefore, energy of these 2 is indicated by 3 by 5 into delta O. This is plus 3 by 5 into delta O. Plus indicates the rise in energy, increase in energy. For these 3 orbitals, energy is decreased. ಇವುಗಳಿಗೆ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತದೆ ಹಂಗಂದ್ರೆ ಹೌ ಮಚ್ than these two. That is represented by 2 by 5 into delta O. It is minus 2 by 5 into delta O. Minus is indicating the decrease in energy. This is what? Crystal field splitting. Crystal field splitting in octahedral coordination entity. Please remember what are the questions will be asked regarding this concept. Okay, you have to explain only this diagram if you are asked in the examination, not this one and not this also. ಇದನ್ನ ಕೇಳಿದ್ರೆ ನಿಮಗೆ ಇದನ್ನ ಕೇಳ್ತಾರ ಅವರು ಗೆಟಿಂಗ್ ಆರ್ ನಾಟ್ ಅರ್ಥ ಆಗ್ತಾ ಐತೆ. ಇದು ಮಾತ್ರ ಕೇಳ್ತಾರ ಅವರು, ಇದು ಮಾತ್ರ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಕೊಡ್ರಿ ನೀವು. ಓಕೆ. ಎಸ್. ಆಮೇಲೆ ಇದರೊಳಗೆ ಏನು ಹೇಳ್ತಾರೆ, ಇದನ್ನ ಡಯಾಗ್ರಾಮ್ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಕೊಡ್ರಿ ಮತ್ತು ಡಯಾಗ್ರಾಮ್ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಕೊಡ್ರಿ, ಡಯಾಗ್ರಾಮ್ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಕೊಡ್ರಿ, ಡಯಾಗ್ರಾಮ್ ಹಾಕ್ರಿ, ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಕೊಡ್ರಿ. ಏನು ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಕೊಡ್ರಿ? ಇಲ್ಲಿ ನಾನು ಹೇಳಿದ್ನಲ್ಲ, ಈ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಅದಾವು, ಇದು ಅಲ್ಲ, ಇದನ್ನಷ್ಟು ಸ್ಪ್ಲಿಟ್ ಹೆಂಗೆ ಆಗ್ತದೆ ಅದಷ್ಟಕ್ಕೆ ಬರಿಬೇಕಾಗಿತ್ತು. ನೋಟ್ಸ್ ಒಳಗೆ ಐತಲ್ಲ ಅದು ಮಾತ್ರ ಬರೀ. ಕ್ಲಿಯರ್ ಆರ್ ನಾಟ್? ಓಕೆ. Now let us discuss about one more point regarding the one more concept in the crystal field splitting, that is crystal field splitting in tetrahedral coordination entity. Okay, it means in a tetrahedral direction the ligands will approach the central metal atom. Okay, in octahedral coordination entity 6 ligands were there, here 4 ligands will be there, but the direction of approach will be different in the tetrahedral coordination entity in comparison with the octahedral coordination entity. Okay, here just assume this diagram. In the cube I have located, I am showing the tetrahedron. Okay, it is having structure like this. To imagine the tetrahedron, you have to assume the structure of the methane. This is methane molecule, 2 bonds. It is indicated like this. It is tetrahedral structure. 2 bonds. If you assume this is the carbon atom, my hand is the carbon atom. This is one bond, this is one bond. Bond number 1, bond number 2. Bond number 1, bond number 2. Here is the what about bond number 3 and 4? Fourth bond is like this, towards you, towards you. And where is the direction of the or location of the third bond? Like this, away from you. One is like this, another one is like this. This is the structure of tetrahedron. This is the structure of tetrahedron. And the ligands kuda tetrahedral direction. Here is the approach. Two ligands are in the same plane. They are approaching like this, here and here, or here. Okay, and remaining two are, one is towards you, another one is away from you. And I have shown the coordinates also here. I have shown coordinates also. What is happening here? Any of and you also know that the direction of the presence of the lobes in the coordinates, on the coordinates, two orbitals dx square minus y square and dy z square are having lobes on the coordinates. Coordinate ga mele bartavu in ಮೂರು orbitals dxy dyz dzx ಎಲ್ಲಿ ಬರ್ತಾವ in between the coordinates. But look at the direction of the approach of the ligands. This is the direction of approach of one ligand. This is the direction of approach of another ligand. This is one more ligand. This is one more ligand. This is fourth ligand. ಇಲ್ಲಿ ನೋಡ್ರಿ, ನೀವು ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೋಬಹುದು. ಇಲ್ಲಿ ನೋಡ್ರಿ, y ಕೋಆರ್ಡಿನೇಟ್ ನಾನು ಜಾಸ್ತಿ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿಬಿಟ್ರೆ ಈ ಪಾಯಿಂಟ್ ರೀಚ್ ಆಗ್ತದೆ ಅಂತ ಅನ್ಕೋಬೇಡ್ರಿ. ಅದು 2 ಡೈಮೆನ್ಷನ್ ಒಳಗ ಆ ಪಾಯಿಂಟ್ ಎಲ್ಲೈತೆ, ಬ್ಯಾಕ್ ಸೈಡ್ ಐತೆ, ಹಿಂದ್ಗಡೆ ನಾನು ತೋರಿಸಿದ್ದಲ್ಲ, ಈ ರೀತಿ ಐತೆ. ಕೋಆರ್ಡಿನೇಟ್ ಇಲ್ಲೇ ಐತೆ, ಇದು ಇಲ್ಲೇ ಐತೆ. It means what I want to tell you that in tetrahedral geometry, in tetrahedral coordination entity, any of the orbitals, any of the 5D orbitals are not approaching the ligand's direction. Any of the ligands or any of the ligands are not in the direction of the presence of the 5D orbitals. There is no direct contact between the ligands and the any one of the lobes of the 5D orbitals. ಯಾವುದೇ d orbital ಗಳನ್ನ ಲಿಗ್ಯಾಂಡ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಅಪ್ರೋಚ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಆಕ್ಟಾಹೆಡ್ರಲ್ ಜಾಮೆಟ್ರಿ ಒಳಗೆ ಏನಾಗಿತ್ತು, ಎರಡು ಆರ್ಬಿಟಲ್ ಗಳು ಡೈರೆಕ್ಟ್ ಆಗಿ ಅಪ್ರೋಚ್ ಮಾಡ್ತಾ ಇದ್ವು. ಯಾವ್ಯಾವು? dx square minus y square and dz square. ಇಲ್ಲಿ ಯಾವುದೇ ಆರ್ಬಿಟಲ್ ಗಳು ಅಪ್ರೋಚ್ ಆಗ್ತಾ ಇಲ್ಲ. But the 3D orbitals dxy, dyz and dzx are relatively closer to the direction of the ligand. How it is here? In the between, you have to imagine here. In the between the axis. In the between the axis. This is in the between the axis. Lobes are present. Those lobes which are present in between are relatively closer to the direction of the ligands. They are also not directly approaching the ligands. They are relatively closer to the direction of the ligands. Therefore, the T2G set of orbitals in this tetrahedral coordination entity will experience little bit more repulsion and their energy is rising. And the energy of the EG set of orbitals will be lower. Therefore, we are having this structure, which is the inverted structure of the octahedral coordination entity structure. It means T2G set of orbitals are having relatively higher energy and EG set of orbitals are having relatively lower energy. This is the concept of crystal field splitting in tetrahedral coordination entity. I have explained each and everything regarding this concept. Only the difference is here. Here T2G set are having higher energy, EG set are having lower energy. Why? T2G set of orbitals are relatively closer, not in the direction, in the same direction, relatively closer to the direction of the ligands. Understood or not? This is the concept.